probability distributions are very similar to frequency distributions that we did earlier this year, except instead of displaying frequency, it's going to display probability. The rest of what we're going to do is very similar. There's significant parallel between the two. So as we work through this a little bit, we're going to tie some of what we did in chapter 4 together to what we did when we were doing frequency distributions, which I want to say was chapter 2. So hopefully it'll all kind of connect up. All right. We have to review, first of all, what discrete and continuous variables are, because you're going to be asked about that in the homework. Okay, even though we've covered this earlier, I'm just putting it in here again. Discrete variables, they can be counted using whole numbers. All right. 1 on up, no fractions, no decimals. Okay. Anything that can be counted using those whole numbers is considered a discrete variable. The other one, anybody remember what the other one was? Continuous. Okay, measured. They can be expressed with intervals. They can use fractions. You can use decimals. That's just kind of review, because you're going to be asked about that in your homework. All right, let's get into what's really happening in this section. Probability distribution. Okay, now the form of these is going to look different than a frequency distribution. Okay, they go in this form. The outcome, the x, is going to be the x, and then the probability is going to be the y. Okay, and we're going to list it in a table like this. And later on we'll have an example and we'll fill this in so you can kind of see how it works exactly. But the best kind of way to do it is to look at an example. Okay. So here would be an example of a of when you would make a probability distribution. Okay. So it'll say something like this: construct a probability distribution for getting tails while flipping a coin 3 times. Now the difference between probability distributions and probability is that we're going to figure out the probability of all the different outcomes that could happen, right? So in this case, if I flip a coin 3 times, you can get so many tails, right? I mean, what's one possibility of flipping a coin 3 times? How many tails could I get? 3. I could get 3 tails. I get tails every time. What's another possibility? 1 tail. What else? 2 tails. 0 tails. Okay, those are my outcomes. I can get 0, 1, 2, or 3 tails. And then, so what we end up having to do is find the probability of each of those, and that's where that's all going to go into the table. Okay, so this is what we talked about, where the number of possibilities, knowing a coin is flipped 3 times, and we just listed those. Okay, so you can either get 0, 1, 2, or 3 tails. So I'm going to go over to the next slide, and we're going to make the sample space, and then we'll come back to this table. Okay, so we got to look at the sample space, and so what we have to figure out then is actually, let me just list it like this real quick. Okay, so these are all tails. All right. So if I flip 3 coins, what is the outcome for 0 tails? 3 heads, right? So I'd have a head, head, head. Right? What are the outcomes, the possible outcomes for 1 tail? 2 heads, okay, so I could have tails first. Heads, tail, heads. Head, head, tails. Okay, you see what we're doing here? Alright. So here's what it would look like. Yes. So this is the sample space. This is all the possibilities here. 0 tails, there's only one way to get 0 tails. 1 tail, there's 3 ways. 2 tails, there's 3 ways. 3 tails, there's 1 way. And so what we're doing in a probability distribution, instead of putting the number of ways that it can happen, the frequency, what we're going to put in the table is the probability of each of those outcomes occurring, okay? So we have to find the probability of each of these outcomes, okay? So what is the probability of getting 0 tails? How many possible outcomes are there total? 8. There's 1 here, 3 here, 3 here, 1 there. There's 8 total. So how many ways can I get 0 tails? 1. But so the probability is then 1/8. What's the probability of getting 1 tail? 2 tails. And 3 tails. So probabilities. All of this is going to now go into the table, and I'll show you how to put it all in the table. Okay. Couple things that you need to keep in mind before we look at the probability distribution. First off, because this covers the entire sample space and all the possible outcomes, okay, the sum of the probabilities has to equal 1, since it covers everything. 1/8 plus 3/8 plus 3/8 plus 1/8 does equal 1. Okay, so that's one way to tell if I'm looking at a probability distribution. All the possible probabilities will add up to 1. What else has to be true about an individual probability? An individual probability, what kind of restrictions does an individual probability have? Numerically speaking.
The top one can't be bigger than the bottom one.
Right? So, okay, so it can't be bigger than 1.
It can't be less than 9.
It can be less than 1.
It can't be less than 0.
Can't be less than 0. Right. Any individual probability must be between 0 and 1. Inclusively, meaning it could be 0, it could be 1, but it's got to be in between there. It can't be bigger than 1, it can't be less than 0. So when because one of the things you're going to have to do is they're going to give you a probability distribution, and they're going to say, or they're going to give you a distribution, sorry, and they're going to say, is this a probability distribution? And those are the things you're looking for to decide. And we're going to do a couple of those, we're going to look at a couple of those here in a minute. Let's get back to making a probability distribution for this. Okay? So, here's what it's going to look like. So here's my probability distribution. Similar table, except now I change the outcome. Because the specific outcome that we're looking for is number of tails. Probability is still going to be here on the bottom. So what's going to go across the top here for number of tails? I'm sorry? 0, 1, 2, and 3. Okay? That's what's going to go up. Those are all the possible outcomes for a number of tails. And then below that will go the associated probabilities, right? Which we just figured out as well. So that's a probability distribution. Listed all the outcomes, found the probability of each outcome. That's probability distribution. So if you're asked to create one, that's what you'd have to do. All the steps that we went through. Find all the possible outcomes. Find the probability of each outcome. Put it in table form, and there's a probability distribution. Okay? Any questions on that? Pretty straightforward. That's for creating a probability distribution. That's it. Yes.
We're done?
No, we're not done. Okay, a couple other things. So one of the things that you're going to have to do, like I said, is identify or determine if a distribution is in fact a probability distribution. Okay? And so here are 2 examples. And this is what it'll look like. Say, determine whether each distribution is a probability distribution. And those 2 criteria that we looked at before, that the probabilities all have to add up to 1, and each individual probability must be between 0 and 1 inclusively. Okay, so let's focus on this first one. Okay, I like to start with the individual probabilities first. Are these all between 0 and 1 inclusively?
Yes.
Okay, what do they add up to?
1.
1/5 plus 1/5 plus 1/5 plus 1/5 does equal 1. That is a probability distribution. That's it. Okay? How about down here? Why not?
Because it's -1.
Okay, I got a negative for 1. I got another one that's bigger than 1. Now, do they add up to 1?
Yeah.
Yeah.
They do, but don't get fooled. It doesn't meet the first criteria, right? The individual probabilities are not between 0 and 1 inclusively. So this is not, and I circled those two that are problematic. Okay, so that's another thing that you're going to have to do. All right, the last thing that you're going to have to do is you're going to graph it. So going back to the same one that we just did, the graph is very similar to a histogram. Just the same way that probability distribution is similar to a frequency distribution, okay, except it's not quite a histogram. There's a little bit of a difference, otherwise it's fairly similar, okay? So first thing, you're going to have a graph like this. The probability is going to be on the vertical axis every time. The outcome, number of tails, is going to be down here on the x-axis. All right. So, notice over here I've got 3 little tick marks that are going to go with these here. So each one of these tick marks is how high do you think? An eighth, right? These are already numbered for us. So that's what the left side is going to look like. Now I put 2/8 instead of 1/4 just to kind of not make you have to convert fractions. 1/8, 2/8, 3/8. Okay, and then the other difference is in a histogram for a frequency, when we use frequency, we would make bars. On a graph of a probability distribution, we draw lines. So meaning, since 0 it's 1/8, I'm actually gonna draw a line like that up to 1/8. All right, and then for 1, I'm gonna draw a line up to 3/8. So same idea, except they're just not bars, they're little lines, and so my final ends up looking like that. So it looks histogrammy. It's just instead of bars, they're lines. Okay? Any questions on that?